Okay, a fresh start. Good afternoon, everyone. I hope you are doing great. I'm gonna close the cam and let's just jump into the topic. Classifying movie reviews, which is a binary classification. You know, this is something that we have talked a lot of time, that why we do not use the same data for training and testing. In that case, if the data has overlap, you are asking a question that you have already given the answer to, and you change the model into a kind of lookup table like an Excel file, which is not the case. We want to predict the labels for unseen data. It says that it is possible that your model could end up merely memorizing a mapping between your training samples and their targets. So the thing is, in the first example of this chapter, we work with IMDb and we pick the most frequent words that we see in the reviews, the most top 10,000 most frequently used words. It is already split into train data and test data and train labels and test labels. Apart from it, if you go to every single train data, for example, the first row, you are going to see there are nothing but just a bunch of numbers, and they are already the codes that exist in the dictionary, but slightly different from the original dictionary, and I'm going to elaborate on that, why slightly different. And the same thing applies to the trained labels. We have a bunch of zeros and ones for positive reviews and zeros for negative reviews, right? We checked that because we said, let's pick the top 10,000 most frequently used words. The index of the words that we have could be between 0 to 9,999. And then we said this is kind of challenging part of the code. We get the words from the IMDb and place them into a variable, let's call it ABC, word index or something. And we say, swap the key values like word and index of the word, swap them to value keys. Then you have numbers and then words. But why we say I -3? The reason for that is, if we look at the original dictionary, it is something like this part that I already highlighted. Like index 0 is for I, 1 is, for example, M, 2 is A, and 3 is students. But when you want to bring it to check by the neural network, you need to consider 3 different reserve places, like 0 for padding. If for any reason you want to have a limited number of words, for instance, 500, so the one that has 300 in the review part, you're gonna 0 pad the rest of 200s to make the size 500. So 0 is already reserved for padding. The other thing is, you see that there are a bunch of zeros and ones. Sorry, look at here. You see that, for instance, this is the first review, end up here. But in order to say, hey, this is the review number 1, you just use 1 as the start of the review. You use 0 pad. For the next review number 2, you're going to use another flag for the start, which is 1. And then here is 0 padding if you want to keep the size of all of them the same, right? Yeah, and the thing is, okay, did you talk about this to me? I received an email, sorry, a private text. If it is about this one, can you please copy and paste what you sent? Thank you. And then for the things that we don't know, the words that are not in the 10,000 picked words, we are going to use unknown. It could be any character. So if we get back to here, we understand that why you are going to get those numbers and say -3, -3. Technically, if you say 3 -3, it brings you back to the original index that you can find in the dictionary. Now it is possible to go and read the text the way that you can decode it. You remember we spent good amount of time. Guys, if this part is clear, would you please type 1? Okay, now we get to the next part and see, it says that you can feed a list of integers into a neural network. You have to turn your lists into tensors, and there are two ways. One of them, as you see in this example, could be just zero padding to make the size of all reviews equal, right? But the other way is one hot encode mechanism. And for saying what it does, you can just again look at this example. Imagine that we want to have top 10,000 words. Then let's consider an array that has 10,000 columns. For each review, imagine that is review number 1. And we have, for instance, index number 2 and index number 4. These words are used in our review, so we turn the zeros to 1. What is the use of it? If you imagine that we have, for instance, 25,000 samples, the neural network is responsible to find the patterns that in which places we have these ones and in which places we have these zeros, and the labels that we assigned. For instance, if you have this one and this one and this one, high probability it is positive, right? And you try to guess based on zeros and ones what could be the sentiment of the review, if it is a positive or negative. Does that make sense? Look at this one. For turning that into one hot encoded, we just use this mechanism, but it's a little bit confusing. I'm going to quickly review this part with you and show how this works. And then we apply that handwritten function to train and test the data part. The good news is you don't need to write the function. You can simply use already existing mechanism to change it to hot encoded. And we convert the labels from zeros and ones into float zeros and ones, because we said that it's easier for neural networks to work with floating types. Before getting any further, let's just get back to the IMDb Colab file that I have shared with you. So let's just run the first one. In the last portion of it, I have used a kind of crazy number of hidden layers. It says run out of RAM. The best is to use Jupyter Notebook on your local computer. And at the moment, we just go all the way to that part, but try the last part that I have mentioned on your computer. So if you see the print of the message shows there are some bunch of numbers like 1, 15, 22, and so on and so forth. And the label is 1, which shows it is positive. We talked about the max, we went through all this. Now just switching these two, if I just say reverse, sorry, get the words, and then here we say show the word index, it's going to show you word and the index of the word. But now if you flip those two and you say now show it to me, it's going to show you the index and word. Now we say go to the indices that we have in the review, means that, guys, we are talking about this part. Go to this part, take 3 out of it. So technically this guy is going to be -2, this one is going to be 11, this one is going to be 19, 13, and so on and so forth. Why? Because we have already shifted 3 seats, and we need to take those numbers from each of those indices. And then we say, now you can just simply show me the review. For instance, this is for the first one, and you see it totally makes sense. But if you do not deduct that number, it's going to be a gibberish. You cannot understand what is going on because the indices are not correctly set. And then I said we import NumPy. We take, but we said this is a little bit confusing. So this is very useful example. Let's say we have values. Imagine that these are the indices of the first review, and these are the indices of the second review, nothing more. So we have 2 reviews. What would be the length of that? It has 2 rows. It's going to say 2. And we say, let's create 2 rows, in the real example, 25,000 rows, and 10 columns, the real example, 10,000 columns. And then if you just say what would be the result, it's going to show you 2 rows, 10 columns, as you see here. Now we say, okay, go to these enumerated values, guys. We are talking about this. And none of these guys are keywords. So if I say I and J, for example, here, I'm sorry, J here, I just need to say I and J here as well. So the first elements would be the sample or the row, and the second one would be those values that we have. So look at what's going to happen. It is going to show you exactly the same thing. So now we can say, hey, go to every I and J, or counts and values in this. And so it's going to be 0 and 3. So it's going to be 0, 1, 2, 3. And then convert that from 0 to 1. Let's look at the things that is happening there. And if you just see the result, you see that we went to index 3, index 7, index 2, and index 7 again, and we convert them, whatever they were, 0, or if it was 1, we just said, okay, convert them to 1. And we did the same thing for the second one. So if everything is clear and you get the concept till this moment, please type 2 this time. Thank you, Ivan. If you have any problem or concern, and if you don't understand any part, please let me know which part you have concern. Minna, thank you. Yawai, Alvaro, Parsa, Anand, Munira. Okay, so thank you, Ali. Let's just get to this. It exactly does the same thing. We say let's have I and sequence, and now you know what is the sequence. It's exactly those indices that you have in each. You're saying what are those indices? It's exactly like what we saw in the first. Go and find each of these indices, and what you need to do is just make them like a vector, 10,000 columns, and go to that row, that sample, and those every single index, and convert the zeros into one. What are we gonna have? The length of this one, the train data was 25,000, and the test the same. If you overwrite it with this vectorized, what do you think the dimension would be? Anybody can guess? What would be the dimension after applying that? That's part of the answer. Ali, can you make it complete? Look at this one. If we apply that, it's going to convert 25,000, just one list, into 25,000 rows. And look at this one. And this is the shape, 25,000 rows and 10,000 columns. Before that, it was just one list of words. Okay, so the same happened to, okay, we convert the labels. We convert the labels from zeros and ones, integer zeros and ones, into float, 0 dot and 1 dot. And we explained that the array 0 is a scalar, but if you just convert it and say show the 0, it's going to tell you that it is 0, which is a floating. Okay, the next part is, let's go quickly. It says that the input data is vectors and the labels are scalars. This is the easiest setup, but we need to do a few things. There is one quick question. What is the factor that converts a linear transaction, like we have dot operation between W and inputs plus B? What changes this dot operation into non-linear thing? Anybody? Raoul Walgor. Yes. That's exactly ReLU. So we are going to get to that in a few seconds. It says that having more hidden units, it is possible that you define, for example, 10 hidden units, and each of them you can have 1,000 neurons. And actually, I did some of those crazy numbers. I used some of them in the example, and we could easily run out of dedicated RAM on Colab. So we need to be careful of the capacity that they have dedicated to us. Otherwise, we need to use our local machine for that. But it says that having more hidden units allows your network to learn more complex representations. That is good, but what if you use such a thing for a simple, structured data set like what we already have? It makes the network unnecessarily computationally expensive and may lead to learn unwanted patterns. Unwanted patterns are the patterns that they are not general enough. You didn't generalize the pattern and you just made them specific to data in hand. That's why it's not gonna do the same on unseen data. So there are two factors that the author provided for us for this chapter. One is the number of layers to use and the number of hidden layers in each of them. And it says for this one, we are going to use 2 hidden layers, each of them 16 hidden units. A third one would be the last layer, the output, which we are going to use. We are going to use the probability for saying if it is positive or negative. And because we have probability that we want to squash into 0 or 1, we are going to use sigmoid, right? Does that make sense? And we talked about a value, which is a function which is going to zero the noise, the negative numbers, and sigmoid that squashes the arbitrary value for the, because, for instance, we don't have 100% positive, 100% negative. We always fly between these two ranges, 0 to 1. So anything which is equal or above 0.5, we consider it as positive. We should shift it to 1. And anything below 5, we should consider as negative. For some of the values, you see that it is obvious. And it says, let me just show you some. We are going to see for some of them, which is 0.1 or 0.9, we are very much confident they are negative or positive. But the gray area around 5 is not very much certain, but we need to make decision to consider if it is positive or negative. So sigmoid is going to help us for that. This is the architecture that we talked about. So we have the input, guys. How many samples we said we have for training? Anyone remembers how many samples? Algor, Anand, Ali, Parsa. Okay. So we said that MNIST has 50,000 samples, 25,000 for training, 25,000 for testing. How many columns? 10,000 top, most frequently used, so that's why. And you see that the input shape says 10,000. That's the number of columns. And it talks about what we addressed a few seconds ago. Let me just quickly read. It says that without an activation function like ReLU or TAMH before ReLU, we used it, or even sigmoid, the dense layer would consist of 2 linear operations. It's going to be .w input, dot operations here, plus bias. So the layer could only learn linear transformations of the input data. The hypothesis space of the layer would be the set of all possible linear transformation. It's not enough for nonlinear things that we deal with in deep learning. Such a hypothesis space is too restricted and wouldn't benefit from multiple layers of representations, because a deep stack of linear layers would still implement a linear operation. Adding more layers wouldn't extend the hypothesis space. To get access to a much richer hypothesis space that would benefit from deep representations, you need a nonlinearity or activation. So guys, I pause here. I say you need a nonlinearity or activation. You're going to see the reason that I paused here. not in the lecture, but in the quiz. ReLU is the most popular activation function in deep learning, but there are many other candidates which all come with similarly strange name, like p-ReLU, LU, leaky ReLU, and so on. And it says that the binary classification problem and the output of your network is a probability. It talks about the parameters that we need to set, like the loss function or cost function, as well as the optimizer, and so on. The other important thing that you're going to see in the quiz as well is mentioned in these 5-6 lines. Look, it says that the cross entropy is usually the best choice when you are dealing with models that output probabilities. So let me ask you, if you have categorical output like MNIST, what would be the best cross entropy? Anyone remembers? In the MNIST example, so I wait for a couple of seconds if you need to search. If it is categorical already, hot encoded, Anand, in that case, what would be the best? Please spend a few seconds. And search. If it is if it is categorical, then categorical cross entropy. But what if it is not categorical in one hot encoded form, and it is like integers 0, 1, 2, 3, all the way to 9? In that case, what would be the best cross entropy? Anyone? It's exactly what Anand said, Lucas Bravo. It's a sparse categorical cross entropy. And what if we have just 0 and 1, cat or dog? What would be the best? What if we have yes, Algor? Exactly. It's going to be binary cross entropy. Let me just say something to one of our team members. I received an email that one of our friends sent an email about one of the topics. I checked, I do not have anything there, just to let you know. Normally, in worst case scenario, I get back to your email in 2 days. If anything happens, please just get back to me again. There's one thing, the system has some constraints that if you use any other email addresses rather than George Brown, it is going to put it into spam or somewhere that I cannot easily find. And if we find it, Albert strongly suggests that do not open any students' email from other sources, and to respect the conditions that they consider those to follow. I do not open. So please just make sure that you send through George Brown email, and then please follow up with me if you do not receive any reply. I'm saying most of the time after 2 days maximum, I reply the emails. Okay, let's go to the next part together. The last thing, yes, for binary is binary cross entropy. The last thing that I want to emphasize is, guys, what is the ground truth? Would you please tell me what is the synonym for ground truth? Is this the prediction? Is it y or y prime? Yes, Lucas, bravo. It is y, right? So the ground truth is nothing but your labels. And here we just use, it says that to configure the parameters of optimizer, you can just pass, look at the difference between these two. So instead of saying just optimizer equal to rams prop, we say go to the optimizers class, and then we define rams prop, and then we define some parameters. Also, it is possible for loss function, you go to the losses and choose binary cross entropy. That is one of the ways you could use your own loss function. I mentioned before that if your model is somehow different from what we have already in the market, you need to define your own loss function. Otherwise, the best is to follow the crowd and see what they use. Also for metrics. And you see here, instead of saying accuracy, we just say metrics binary accuracy, right? What did we do here? This is the part that we addressed before. We talked about it before, but this is the time that we implement it. If you go to the Colab file that we have provided, you can see we import Keras, and inside Keras we import models and layers. I mentioned intentionally, sometimes you see that because of the version incompatibility, you need to work with TensorFlow.keras, not directly Keras. So sometimes if you see that there is an error here, the easiest way, before checking anything, just say TensorFlow.keras and see if it works or not. So the other part is saying the models should be sequential, right? And then we take care of the take care of the architecture the way that we have 2 hidden layers. Each has 16 neurons, and the activation for the hidden layers would be ReLU, and the last layer just has 1 neuron because it should give us just positive 1 or negative 0. And sigmoid, we know that the top 10,000 words, we talked about it. And after that, we said, let's import optimizer. And then we said, let's have the parameter for rams prop, as well as defining something different for loss. Instead of just saying simply, we could just say binary cross entropy or binary cross entropy dot accuracy for matrix. I've just provided this as one example. And here, as you see, it says the LR or learning rate is LR is replaced by the learning rate. So the thing is, for today, because it needs totally a new topic to explain, I just pause it up to this page, and that is validating your approach. and that is the validation data set. So we have train, test, and validation set. We are going to talk about this. We have talked about it a little before, but we are going to extensively elaborate on that and check what is happening in here. So tomorrow we're going to start from this one. Please make sure that you bring this file. We quickly go through those selected parts that we ran, and then we continue from there. Before I leave, I want to address two things. Would you please check your course and the test parts, the quiz? Would you please confirm that you can see the quiz? Let me just go there. Thank you very much. And is it possible to start? I don't want you to start now, just I want to make sure. Okay, awesome. There is one thing that I want to tell you. You know that next week we are going to have a family day. So Monday we don't have any class, right? In that case, technically we shouldn't have any quiz, but the problem is then I should pick top 8 out of 10, not 11. So I thought that it's not a bad idea that I create another quiz number 6, based on the things that we learn in the next labs session. And I'm gonna extend the time to Sunday evening, 11:59. And then you can just answer it at your convenience. So you have 3 more days compared to normal cases. And the good thing is we can use it and leverage it to review the stuff before the midterm. So do you have any objection? If you accept that idea, please type 1. If you have any objection, please type 2 and give me alternative what would be the best if you want. Okay, so I consider that, thank you very much. I consider that there is no objection. Again, the code for today's add class is 5JVZ. Tomorrow we are going to continue talking about validation data set, the usage of it, and how we are going to apply it in our models. Thank you very much. Have a wonderful day and see you tomorrow. Thank you a lot.